Okay, so ready to dive in. Today we're going deep, really deep, into this wild idea of like simulating like a quantum computer inside a regular computer.
Okay.
And it's a little dense, I'll be honest, but it basically says we might be able to use like digital numbers to like create this virtual space that acts like the fabric of reality.
Oh, wow.
It's a lot.
That's ambitious.
It is. So I definitely need some help unpacking this one.
Okay, well, I mean, where should we even begin?
I guess, like, what's the core idea here? I mean, how do we even start to think about building a quantum computer?
Well, it's kind of like, have you ever used, like...
Inside a normal one.
Yeah, like a virtual machine on your computer.
Right, yeah.
So, like, usually that lets you run a different operating system, but in this case, we're talking about simulating the actual laws of quantum mechanics.
Okay, so we're not just running a different program.
No.
We're, like, building a mini universe inside the computer.
Yeah, it's like a mini universe that runs on these things called fermionic RCBs.
Okay, stop right there.
Okay.
Fermionic RCBs.
Yeah, it's a mouthful.
What even are those?
So think of them as kind of like virtual particles that move around like, electrons in a computer chip.
Okay.
But here's the thing.
Yeah.
These virtual particles, they behave according to the rules of quantum mechanics.
So they're not just like...
They're not your normal particles.
Regular bits.
No. They're these weird quantum things.
Okay, so how does that even work? I mean, how do they actually do calculations?
Okay, so in a normal computer, information is stored in a fixed, physical structure.
Yeah.
But in this simulation, the computer space itself becomes the calculating machine.
So the computer's reality is doing the computation.
It's like the reality itself is calculating.
That is wild.
It is pretty wild.
Okay, but how do you even program something like that?
That's the million-dollar question.
Yeah.
It's not like writing code in the traditional sense.
Yeah.
It's more like defining the properties of this virtual space.
Right.
So like its shape, its elasticity, how those RCBs move within it.
So we're basically like...
We're playing God.
Designing the laws of physics.
Yeah, for this digital universe.
For this little world.
Yeah.
Okay, and this is where the source makes this pretty bold claim.
Yeah.
It says that this whole approach could challenge the assumption that quantum computers are like fundamentally different and more powerful than classical computers.
Yeah, that's a big one.
So what are the implications of that?
Well, I mean, it's always been assumed that some problems are just too complex for, regular computers.
Yeah.
But maybe, just maybe, quantum computers could be the key to cracking those problems.
Okay.
So if this simulation idea actually works, it could mean we don't need
to build these.
To build entirely new types of computers.
Crazy new computers.
Yeah, to solve these really hard problems.
That would be huge.
It would change everything.
But the source, it doesn't stop there. It goes even further. It suggests that all of this, like this whole idea, points to a deeper understanding of reality itself.
It gets pretty philosophical.
Okay, lay it on me. What is this deeper level of reality?
It's about seeing reality in terms of these three core components.
Okay.
The first one is the shape and properties of space itself.
So like the actual fabric.
Yeah, the fabric of space.
Reality.
Exactly.
Okay.
The second component is the symmetries within that space.
Okay.
And how they, break or change.
So like patterns and how they're disrupted.
Yeah, exactly. And then the third one is how that space deforms over time.
Okay, so... Wait, time is like...
Time is like a side effect.
A side effect of space changing?
Of space deforming, yeah.
So gravity, the laws of physics, it's all just...
It all comes down to space doing its thing.
That is mind-blowing.
It's a big shift in perspective.
It really is.
Yeah.
But, I mean, this is all theoretical, right?
Well, yeah. Realizing this concept is one thing. Actually simulating it, that's a whole other challenge.
Yeah. So... What are the roadblocks here?
The text outlines three big challenges.
Okay.
First, we got to figure out how to give this virtual space the right kind of like elasticity and resistance.
And like make it behave?
Yeah, like a real fabric.
Like a real fabric.
Exactly.
Right.
Second, we got to incorporate the more complex properties of reality, things like fields and forces into the shape of this virtual space. And then finally, we need to actually demonstrate how this resistance in the virtual space leads to the large-scale structure of the universe that we see.
So we're still a ways off.
Yeah, we're not there yet.
From building this perfect simulation of the universe.
It's going to take some time.
Yeah, I mean, these are some pretty massive challenges.
They are, but, even attempting this kind of simulation, it pushes the boundaries of what we know. About the universe.
That's pretty amazing.
It is.
We started with simulating a quantum computer and ended up rethinking the nature of reality.
It's all connected.
It really is.
Yeah, definitely.
So until next time.
Until next time.
Keep on diving.
Keep on searching.